to take a look at exponents, and we're going to dial it back to the basics of exponents as well as polynomials to look at what we can do to simplify them and the different rules that apply to exponents. So the key here for exponents is that we have a completely different set of rules for arithmetic with exponents. It's not going to operate the same way that numbers do. So it's a good strategy to be able to copy down the different formulas when I show the formula sheet, so you've got a point of reference for what to do with the exponents. So recalling from what we've previously learned, that if I have something squared, it's 5 times 5. 5 would be considered the base, 2 would be the exponent, or we could also call it a power. It's called an exponential expression because it has an exponent. And just like when we have x, we don't write 1x. If something has an exponent of 1, we don't typically tend to write it. So if I want to write 2 times 2 times 2 in an exponential form, the base would be the number that's being multiplied by itself. So in that case, this would be 2. I'm multiplying it 3 times, which would be 2 to the third power, which equals 8. The Web 2.0 calculator is the provided calculator for the class. You can type in 2 exponent 3. The exponent key is the symbol above the number 6, and that would give you 8. You are not expected to be able to evaluate all the exponents within your mind. So here are some additional practice problems where we want to identify the base and the exponent. So if I look at A, my base would be 2. Why is the base not negative 2? If the base was a negative, it would be inside of the parentheses. This is a place where we have to really be careful. And my exponent would be 6. And so in part B, I have that exponent inside, so it is part of my base. Then I have the exponent of 6, which would be the same as doing it, multiplying it by itself 6 times. So what you can see is I have a difference in the sign of my final answer. And that's because when the negative is out front and not in a parentheses, it stays out front. When it's inside the parentheses, it is a part of the repeated multiplication, so you have to follow those rules. So this is where I said we're going to see some really different behavior with exponents. When I multiply two bases that are the same, I add their exponents. I don't multiply them, I add them. Our logic tries to tell us to go ahead and multiply those exponents, but that's not what's happening. This is a rule, so you need to copy it down and keep it in front of you until you can get enough practice to remember it. So in the example, 6 squared times 6 to the 5th, my base is 6 in both expressions, so I do 2 plus 5, which is 7. Here, in part A, my base is negative 7. My bases are the same, so I'm going to do 5 plus 3. And that negative is going to remain inside the parentheses. And the bottom one, notice what I did with the numbers. The numbers are not a part of the exponent, so I went ahead and multiplied them together in front. Then I have p to the 5th times p to the 8th. I have the same base, so I'm going to add my exponents. And the negative is out front, so it remains out front. It's not a part of any of the exponential bases. These are some continued product rules that you can practice and pause the video. Now, in part E, I cannot apply the product rule because 4 and 3 are not like bases. So you cannot add the exponents of 2 and 5 because 4 and 3 are not a like base. But I can type that into my calculator and get a final answer. So while I can't simplify the exponents, I could still find an answer. If I look at F, again, the product rule here does not apply. Why not? Because it's 6 to the 4th plus 6 squared. So a lot of times we see that and we think, okay, 4 plus 2. You can only add the exponents if you're multiplying the base. So F is a mistake that is commonly made when you're working practice problems because your brain just gets in the pattern of add the exponents, And it doesn't even register the fact that that's a plus sign and not multiplication. So watch very carefully to make sure that you're catching all of this. Again, I can't combine my exponents, but I can simplify this. So now we're going to use a new rule here. This is called the power rule typically. And this is when I'm raising an exponent to an exponent. It looks very strange in a problem. If you look at the example, I have 3 squared raised to the 4th power. So it's an exponent of an exponent. And when that happens, what the power rule says is I do the multiplication of them. So when I multiply, I add. When I raise an exponent to an exponent, I'm going to multiply. So if I have 6 squared raised to the 5th power, I'm raising an exponent to an exponent. So I'm going to do 2 times 5, which is 10. Pause the video for a second and try part B on your own. It's an exponent raised to an exponent, so I'm going to multiply. And then I'm going to simplify it to get z to the 70th power. Now we have another rule. This is the power rule part 2. So I'm raising something in parentheses to an exponent. If you remember the distributive property, we recognize that property from having a set of parentheses with a number in front. This is kind of the exponent equivalent to that. I'm raising something in the parentheses to an exponent. So what I'm basically doing is I am distributing that exponent to every term inside the parentheses. So if you look down here, I brought the 5 to the 2 and the 5 to the p. I can figure out what 2 to the 5th is, so in my calculator, I could further simplify this by typing in 2 to the 5th to get the exact value. So here are some more examples. The 5 has to be distributed to everybody. So it's going to go to the 3, it's going to go to the a, and it's going to go to the b. It doesn't matter if they're like bases. And I separate it like this for a reason. Because when I have a squared to the 5th power, I know that I need to multiply. That's an easy step to skip when you're just trying to do it all at once. So for the first couple of problems that you try, it's a good habit to go ahead and separate these out and distribute the 5 in this manner. Now I'm going to do 2 times 5 and 4 times 5 because that's my power rule, and I'm going to simplify it. Where did 243 come from? Because I did 3 to the 5th power in my Web 2.0 calculator. So go ahead and pause the video and give B a try on your own. Notice as I simplify B, that negative is inside of the parentheses. So when I distribute the exponent, the negative remains inside the parentheses, which is going to be important because when I enter this in the Web 2.0 calculator, I want to enter it with the parentheses and the negative value. Where does m to the 2 times 3 come from? Because this would be m squared raised to the 3rd power, which is 2 times 3. Now we're going to have what we call the power rule, but notice I'm dividing something. So this is not the quotient rule that's referenced in the objectives for the week. This is still the power rule, and what this says is I'm just distributing the exponent again. It's a different way of looking at the previous slide. I'm going to distribute the exponent to the fraction, to the numerator, and to the denominator. So if you look at the example, I have 5/3 squares, so I'm going to give the 5 an exponent of 2 and 3 an exponent of 2. I could then simplify it into 25 over 9 by using the calculator to expand those powers. In A, I'm going to do the same thing. I have a fraction. I'm going to distribute the exponent to the numerator and the denominator. I can find 3 to the 3rd in my calculator, so I'm going to go ahead and type that in and find out that it's 27. Go ahead and pause and give number B a try. So you're going to distribute the exponent to both, and then we're going to use our calculator to simplify 3 to the 5th power, which is 243. This is a kind of a slide that is put together to be a quick reference slide of all the rules that we've gone over. I strongly recommend for you to pause the video and to copy this down with the examples and keep it in front of you as you work problems in this unit. it's going to be basically your reference sheet. This is how you know what to do with the exponents. And then as you practice, you will find that you need the sheet less and less. That's the goal, is to work away from needing this sheet. But when you are first practicing, I want you to have it in front of you so you can get used to the rhythm of these types of questions. Now we're going to look at some combinations, and this is where students can get a little lost because there is more than one way to get to the final answer. It does not matter what you do first in part A. It doesn't matter if you distribute the 4 first in the first fraction, or if you distribute the 2 first in the second parentheses. It doesn't matter. You just have to choose the order that you go in. So what I chose to do was to distribute the 4 and the 2 at the same time. Why did I put it over 1? I put it over 1 because I have a fraction in the first half of the problem, so I'm probably going to need a fraction in the second half. So what I did was I took the 4 and I distributed it inside the parentheses. Then I took the 2 and I distributed that inside the parentheses. I typed 2 squared in my calculator, 5 to the 4th in my calculator. This is as far as I can go. There's nothing further I can do. In B, I have to distribute the 2 to everybody in the problem. That means the 5 gets a 2, the third power gets a 2, and the denominator also gets a 2. I can figure out 5 squared in my calculator, and then for k to the third squared, I have a power rule for that. I'm going to do 3 times 2, which is 6. In part C, again, I am distributing first. The distributive property always comes first. I give everybody a 3, everybody a 4. Now I can apply my rules. I'm going to enter -3 cubed in my calculator, and I'm going to get -27. X to the third, 2 times 3 is 6, 2 times 4 is 8, y to the 4th is 4. But I'm not done, because I have like bases that are being multiplied, which tells me I have to add the exponents. So 3 plus 8, 6 plus 10. So now let's look at exponents in a few geometric problems. If I want to find an expression that represents the area of a rectangle, the area of a rectangle is the length of my rectangle times the width. So in this case, I have 8x to the 4th times 4x squared. So I can do the 8 times 4, which is 32, and then my exponent rules say when I multiply x to the 4th by x squared, I'm going to add those exponents to get x to the 6th. The key to being successful in this unit is going to be to rewatch the video, work the examples with me, and then to copy down that formula sheet where I have all the different formulas on that slide.